Hello and welcome back. Today we're going to talk about something very important in math. It's called the fundamental theorem of calculus, or what we call the FTC for short. The fundamental theorem of calculus, it harkens back to earlier this year when we said we can find area under a curve by using what we call the definite integral. It was a definite integral, and this finds us area. For example, let's say we want to find the definite integral from 0 to 2 of x dx. We did this earlier by drawing a picture and using a geometric formula. For example, this is the function y equals x on the domain 0 to 2. And if we look at the line y equals x from 0 to 2, this forms a triangle. And we said we can evaluate this integral here by just looking at the area of a triangle. 1/2, the base down here is 2, and the height is 2. So we can say this is 1/2 area of the base, 1/2 base times our height of 2, which is just 2. However, what if we wanted to try to find the area of under a parabola? For example, like if I draw this parabola right here, and we want to find the area from 2 to 5. Well, we can't get the exact area. So we said we can approximate this by using what we called a Riemann sum, or using rectangles. And another way we could have solved it is by using trapezoids. But we could not find the exact area. For this is what we need the fundamental theorem of calculus to solve for it. And just like what the definite integral does, this just finds area under a curve. So let's talk about what the fundamental theorem tells us. If a function f is continuous on a closed domain and has an antiderivative, in other words, we can take the antiderivative f, then we can say this. The area under a curve is equal to the difference of the values of the function. Now this is one way we can write it, where in the first case we say f prime of x is just little f of x. And both of these, what they just say is just that the area, to get the area, we just need to find the difference in the values of a function. So this is the format we tend to use the most for the FTC. If we take the antiderivative of f prime, we're going to get the function itself, f of b minus f of a. Now, hopefully this should look a little familiar. It almost looks like the top of the average rate of change. That's going to be a lesson we're going to talk about in a couple of days, how it relates to that. So what the FTC says to do: determine if the integral is definite. Look at the bounds, or indefinite, no bounds. The indefinite, what we did the other day, indefinites are where we're going to add that plus C1. Take the antiderivative, and then the third step, apply the FTC. Find the difference in the values of the bounds, and then step 4, take a lap for victory. So let's see here. Let's take a look at this one right here. If I want to find it, so this is the same problem as we had above, so we know the answer should be 2. So let's see if we can get 2 if we solve it. Our first step, first of all, this is a definite integral. So once I recognize this as a definite integral, I just integrate it. And this just becomes x squared over 2 plus c1. We're going to talk about what happens to the C1 in this problem. Something really neat happens here, which we'll talk about in just a few moments. So what we're going to do now is we're going to evaluate it. We want to find the difference in the bounds. So we write this little vertical bar right here. That just tells me I am now going to evaluate this from 0 to 2. Next comes the FTC step. And the FTC step says I'm going to find the value at 2, and I want to subtract that from the value at 0. I'm going to open up some parentheses here. If I plug in the 2, here, if I plug in 2, we get 2 squared, which is 4 over 2 plus C1. If we plug in the 0, we just get 0 plus C1. So let's evaluate. Let's see what this happens here. Here, I'm going to get 2 plus C1 minus C1. Notice the constants will cancel, and they will always cancel, which is going to give us the answer of 2, which is exactly what we had up here when we just used the formula. Now, where for a formula like for a definite integral like x dx, I could use a geometric formula. What tends to happen is we get integrals like this, like x squared plus 1, where we can't solve them and get the exact value. But notice we do get the exact same area using our FTC. So let's take a look at a few more examples. Question number 1. We want to take a look at the area of this line x minus 3 from 1 to 2. So my FTC says integrate it first. Take the antiderivative. We get x squared over 2 minus 3x. Next, we're going to evaluate that from 1 to 2. And this is our FTC step. Find f of 2 minus f of 1. We're not going to simplify. We just want to get an answer. So if I plug in 2, I'm going to get 4 over 2 minus 3 times 2. Plug in the 1, I get 1/2 minus 3 times 1. I might clean up a little bit. I mean, I'm okay if you leave it like this. This is okay on the AP. But this just becomes 2 minus 6 minus 1/2 minus 3. And that's a little bit more accurate. And there's our answer. You can clean this up if you want to. This becomes negative 4 plus 3, or negative 1 minus 1/2, or negative 3/2. I'm probably wrong on my arithmetic there, but that's why we say don't simplify. So let's try number 2 here. Now remember, for number 2, there is really a 1 here. So if we integrate it, this becomes just x. Now notice what I didn't do here. I didn't put my plus C1. Why don't I put my plus C1? Because the C1s are going to cancel. And that's why I don't have my C1 right here. So the C1s, the C's on a definite integral cancel. So therefore we don't actually need to write them. So I can just leave it as the x. And then this is just my FTC, f of 2 minus f of 1. And this just becomes 2 minus 1, whatever that is. I think it's just 1. And there's our area. So let's make this a little bit harder. Let's take a look at the next one, number 3. Now for number 3, be careful. The 4 is a constant. I am just going to bring that out to the forefront. X minus x to the 1/2 dx. My first step is to integrate. We get 1/4. Ready? Let's write this out. The antiderivative of x is x squared over 2 minus x to the 1/2. When you add 1, we get to the 3/2 times 2/3. And we're going to evaluate that from 0 to 1. And let's see what this equals. Using the FTC, again, I don't need to put my plus c because it's just going to cancel. When you do the FTC, f of 1 minus f of 0. And big parentheses. You're going to like 1s and 0s. Both of these are going to have a 1/4 in front of it, so I should put my 1/4 here. When I plug in the 1, I'm going to get 1 squared, which is 1 over 2, which is 1/2, minus 1 to the 3/2 is just 1, so minus 2/3. And plug in 0, I get 0 minus 0. You can leave it like this. That part's just 0, so I don't have to worry about it. So there's my answer. All right. Hope you enjoyed this video. Go back to video number 2, and we'll take a look at some more examples. I'll see you then.